Hey guys, how are you? This is Tutor for Hire again, back at you with the second installment of the calculus series. The title of this video is growth rates because it is about the growth rates of functions. So, if you remember in the first video, I wrote, and this is like the sentence that defines calculus is about functions and finding their growth rates. So in the first video we talked about functions and we said that functions are mathematical systems which have inputs and outputs. The inputs or x values constitute the domain of a function, and the outputs or y values form the range of a function. And each x value corresponds to one y value. Ultimately, a function is a set of all input-output pairs in a mathematical system. So that's what we talked about. And just for a quick example, y sub x is equal to 2x. This is a linear function. This is something we talked about. It has a linear graph. It's very simple function. You put in, say you put in an x value of 1. So you put in an x value of 1, you get a y value of 2. And then you do that, you put in a x value of 5, you get a y value of 10. So that's basically what it is. We've seen the x and y table. You've seen them with the x and the y and the 1 and the 2 and the 3 and the 4 and that stuff when you're younger. So that's what a function is. If you're taking calculus, you probably know this, but it's a good refresher. So moving on to the growth rates of a function. The growth rate of a function. Right off the bat, the growth rate of a function corresponds to its slope when the function is graphed. So hear me and hear me well. The growth rate of a function corresponds to its slope on a graph. They are the same. So the big question is, if you're looking at a function, how do you find the growth rate of that function? So there are two methods. Method one, we have you compute a limit for the function. So what we're going to do is we're going to take the change in y divided by the change in x, and we take the limit of that ratio as the change in x going to 0. But first and foremost, let's get something out of the way. This formula right here, this change in y over change in x, it's also known as, and also can be seen as, I don't have the symbol on here, but the triangle to the y divided by the triangle to the x. But something you're going to see much more common than that even is the dy over dx. This is derivative notation. It's something that means the change in y over the change in x. This is something you're going to see a lot of, so you're probably going to want to get used to seeing that. So yes, you get this ratio. You get this ratio, and then you compute a limit with the dx going to 0. We'll get into this later on in the course, but this is the first method for how you find the growth rate of a function. Method 2 is you follow a rule to produce a new growth rate from known rates. Something like this may be, if I'm not mistaken, y sub x is equal to 2x. Say we know the growth rate of that, we know what it is. You may be able to deduce y sub x is equal to 4x. You may be able to deduce a growth rate for that one. You're not going to be able to deduce the growth rate of something like this from these two. You're just not going to be able to do it because they're way too different. So for this one, you would have to compute a limit for the function. You would have to take the limit of this function with dx going to 0. That's what you would have to do. So let's talk a little bit more about, because we've established how to find the growth rate of a function, and we talked about how the growth rate of a function corresponds to its slope. Let's talk a little bit about the slope of a graph. The slope of the graph, in very broad terms, is the distance up divided by the distance across, also known as y2 minus y1 divided by x2 minus x1. This is equal to dy over dx. So that's basically the slope of a graph, and it corresponds very much to the growth rate of a function. And the slope of the graph, this would be, all of this would be the average slope on a graph. And we say average because a slope in some cases may change. And so let's talk a little bit about that first and foremost. So let's say we have the function y sub x is equal to 2x. And let's take the points x equals 4 and x equals 2. And we're going to compute it to see what the slope is for these. So we're going to use this formula, and we're going to have, on the top, we're going to have 8 minus 4, because if you plug in 4 for x, the y value will be 8. And then if you plug in 2 into x, the second y value will be 4. And we're going to have this over divided by, if you plug in 2 into the function, or let's go ahead and you're gonna have 4 minus 2 for the bottom part, because it's just gonna be the x values. So what do we get here? We get 4 divided by 2, which is equal to 2. That's the average slope. For that function in those points. Now let's take another value and let's see if the slope changes for this one. So let's say 6 and 3, or you know what? Let's do 10 and 20. Okay. So let's plug it in. So if we have 10, we're gonna have 20, or you know what? Let's switch it around, because this is just kind of obnoxious. Let's just do 10 and 5, because that'll be easier. So we're gonna have 20 minus 10. That'll be on top, and then we're gonna have 10 minus 5 on bottom, divided by 10 minus 5. And we're gonna have, and for this we're gonna have 10 divided by 5, which is equal to 2. And you see the average slopes are the same. Therefore, this slope does not change. This is a constant slope. No matter what you put into this function, the slope will always be constant. Now let's look at something where the slope is changing. Something like, something like this. With this function, the slope is consistently changing. So let's do the same points. Do that. We'll do that. And so for the first one, we're going to have 16 minus 4 on the top, divided by, and we're just plugging in these numbers into that function, and we're applying it to this right here to find the slope of a graph. So 16 minus 4 and then divided by 4 minus 2. What do we get here? We get 12 divided by 2, which is equal to 6. Now let's try the second one. We're going to have 100 minus 25 divided by 10 minus 5. And this will be equal to 75 divided by 5. And this will be equal to 15. So as you can see, for this function, the slope is changing. You'll have a slope of 6 at these points, and you'll have a slope of 15 at this point. So the slope is consistently changing for this function. For the other function, it was not. For this function, it is. So the slope is constantly changing here. Where's it? How do I do another one? Just do another one. 2x. This slope is consistent. This slope is changing. But either way, we refer to, when we compute it, we refer to it as the average slope, because the slope can theoretically change. And so that's basically it about the growth rates, is you have those two methods to find it. We're going to dive way deeper into those methods and to figure out known growth rates. We're going to figure out just the first one, the computing it to the limit and things like that. And over time, we're going to get much, much better at this. But so far, so good. I'm really happy with what we're doing this far. And I'm going to give you guys a couple rules just so you can put these in your notes. None of this stuff you have to put in your notes. You just have to think about it. But whenever I say put these in your notes, you gotta put them in your notes. So the growth rate, when we have this, that means the growth rate. The growth rate of a constant, and you know what? Let's talk about what a constant is. Whenever you see the big capital C, that equals a constant number, also known as 1, 2, 5,000, 10,000, 7. Anything where there's no variable is a constant. So if you're taking the growth rate of a constant multiplied by a function, what you're going to get is a constant multiplied by the growth rate of the function. This is the first formula that you're gonna need to know. That's what you're gonna have to figure out. You're gonna have to get there pretty quickly. And here's another one: dy over the growth rate of two functions. We'll put a little one here, added together. The formula for this will be the growth rate of the first formula plus the growth rate of the second formula. This will be the second formula that you guys will want to learn pretty quickly. And let's do a random one and see if you guys can do this. Let's see the growth rate of something like this. So we'll have a constant multiplied by formula 1 plus, we'll just put formula 2, and we'll put them all around a giant parentheses. So pause the video, see if you can figure it out. If not, I'm going to do it right now. So the answer is you'll have C multiplied by the growth rate of the first formula plus the growth rate of the second formula. And this isn't something you have to memorize, but it's just logically deduced from the first two formulas. But anyway, I thank you guys so much for watching this video. Keep working hard, and you guys are going to do great, and we're going to keep going. I'm going to upload every day a new video of calculus, so I appreciate you guys, and let's keep it going. Thank you.